Hello class. So today we are going to be starting the topic of web security, which we will be doing for the next 3 or 4 lectures. And I decided to try, as you can see, a slightly new format just for today. And the primary reason is because when I do this topic, I generally spend about 3/4 or even a whole lecture explaining the basic concepts of web security on the whiteboard. So I'm going to try to replicate that experience over here today in my office whiteboard. And following this, we will then be looking at the slide material. So there is going to be some overlap of material between what I talk about in the whiteboard as well as what is in the slides, but that is intentional. That is to, in some sense, reinforce the understanding of the various actors in the web ecosystem. You will find that when we are covering this particular topic, that in fact the security considerations that we have considered thus far, for example, when we are talking about memory errors and also various kinds of isolation and sandboxing techniques, that the security considerations over there are rather different than the security considerations when you're talking about the subject of web security. So let us get started. In fact, the languages are going to be different, the actors are going to be different, the programs are going to be different. So let's get started, right? So when we consider web security, let's first try to understand what the ecosystem is made up of, and then we will look at the threats that arise in this ecosystem. So when you talk about web security, what are the first things that come to mind? Well, of course, when you talk about the web, the first thing that comes to mind is the web client. This is somebody like you sitting in front of your web browser. Okay? So within your web browser, of course, you will have various tabs within which you do your browsing. Maybe this is your current tab and you're logged into a particular website called www.x.com. Okay? So that is you sitting in front of your web browser. On the other end, of course, there is the web server. And this is the web server of x.com. X could be Google, X could be Amazon, X could be Microsoft, whatever it is, right? You go and visit a particular web server and you try to get content served from them. So this web server is sitting over there and is serving you content over the internet. Okay, so how does the whole thing work? Well, you enter the domain name in your web browser and out goes an HTTP or an HTTPS request. So we will just talk about HTTP because HTTPS is nothing but HTTP running on top of TLS. Right? So here is your HTTP request. This is generally called an HTTP GET request, and it's directed to this particular IP address. And the request goes over to the web server, which then sends back content that is displayed in your web page, right? So here it is actually going to send back content that is displayed within the web browser. Displayed, or we will use the term rendered within the web browser. Okay, the same content is displayed or rendered. Okay, so now that we have a basic understanding of all of the various components, let us try to understand what these components are written in, right? So here is your web browser. It could be something like Chrome, it could be Firefox, it could be Safari, doesn't matter what it is. It's one of these popular browsers that you're using. And it is written in a combination of C, C++, and also Rust increasingly. Okay, So C, C++. It also contains code in lower level languages such as JavaScript. Okay, so this code over here is got the responsibility of actually displaying this content on your web browser. Okay, so now what happens is that when you send over this HTTP request over to the web server itself is written in various languages. It could be written in a language like PHP, it could be written in a language like Ruby on Rails, or it could be written even in a low-level language such as C. It could be written in Java, whatever it is, right? The web server's job is to take requests and generate web pages for you. Okay, so the web server, as I've shown over here, is a fairly standalone web server. What does it send back content in? Well, the content that it sends back over to the web browser is a combination of things like HTML, it could be XML, it could be cascading style sheets, and it could be, very importantly, JavaScript. So a combination of some such content is either statically obtained from the web server in the sense that it resides on the web server and the web server just serves that content, or it could be dynamically generated by this web server and the whole content is sent back to the web browser where the HTML markup language instructs the web browser on how to render the content. All right, so that is what happens between the web server and the web client. Of course, web servers are not this simple. If you were to think about a web server, for example, one that Amazon uses or one that even Google uses, web servers are not standalone entities. They typically interact with a backend database, right? The popular term that is used to refer to web servers, for example, in the cloud setting, is the term LAMP stack, right? So the term LAMP stack generally stands for Linux running Apache, where Apache is the web server, which in turn runs MySQL, which is a database, and on top of that, you have a PHP-based web server, right? So this is just one example of a popular web stack, but essentially this web server might interact with some backend database server, right? So maybe this web server, for example, is Amazon, and the Amazon web server needs to interact with the backend database of products, for example, that are stored in that Amazon has to sell. And the shopping cart application itself is probably going to be implemented inside this, but the database is going to tell you, what products are on sale, what is the price, and so on. Okay, and generally speaking, the web server and the database interact via an SQL interface. So as you well know, databases speak the language of SQL. So the web server generates SQL code, which then sends to the backend database, which then produces content and then sends it back over to the web server, which can then choose to render that content in some appropriate format, right? So for example, you might send an SQL query for all books related to security, right? And the database looks up all books with the keyword security, and it's going to return back a list of books which are then rendered to you in which this web application then takes and then produces HTML code that's going to render this list of books in some format, which are then sent back to your web browser. Okay, so that is how the entire web ecosystem works. Now, given all of this, let us talk about some additional content that is probably of relevance to security. So whenever we talk about security, of course, we are going to ask ourselves, who is the attacker? Who do we really think is going to compromise our our world over here, and what are they going to compromise, right? So what are the things whose confidentiality and integrity and availability we care about, and where does this attacker sit? Okay, so it so turns out that the web ecosystem is actually rather complex, that it's impossible to give a single definition of an attacker. And therefore, we have to think about attackers in various settings. Okay, so we have to think about an attacker from the web browser and the web applications point of view as concerns the web browser, the client side. And we have to also think about the attacker from the web server's point of view, because whenever requests come from here, they are coming from the untrusted internet, right? So we have to think about the security of the web server over here as well. And also the database, because the SQL queries that are probably going to be generated by the web server to this database are going to be generated by this web application in response to requests that are coming from the internet. Okay, so we have to think about the threat model in each one of these cases. So let us think about the threat model, the various pieces of the threat model. Okay, so first of all, let's look at the easy side, the web server side. On the web server side, we have requests that are coming from the internet, and so these are untrusted requests that are coming from the internet. And so we must have some way of making sure that these untrusted requests are properly vetted by this web server. Okay, so the untrusted requests, for example, can come in the form of form fields. That, so you know, if you've got a web page that's displayed over here, the web page may have form fields like a login field, a password field, or any other free-form text field that the end user is allowed to enter. And as far as this web server goes, any arbitrary entity that it deals with on the internet is potentially an attacker, potentially untrusted. And so the attacker, for example, may try to take over this web server by inserting arbitrary input in the form fields that are displayed on the web page, and then send maliciously crafted HTTP requests over to this web server. Okay, so untrusted requests can be used to take over the web server. And so, for example, if you have a web server written in a language like C or C++, it is vulnerable to traditional buffer overflow attacks that can be used to take over the entire web server. That's one class of attacks, of course. There are also other classes of attacks where unsanitized input from the web server side can be used to take over the control of the web server itself, and we will talk about variants of those attacks, right? So, but the net idea over here is that every request that comes to this web server must be considered untrusted and therefore must be vetted. Okay, so the same untrusted requests are sometimes also used to generate these SQL queries, right? The web server is generating SQL queries for the backend database using inputs that it gets from the client. And so, for example, you know, if this database is something that requires authentication and the user has credentials, login password credentials, generally speaking, what happens is that the login password credentials are obtained from the web page, which are then transmitted over to the web server. And the web server simply takes those login and password details and creates an appropriate SQL query to go and authenticate that user into the database. Okay, so what the user enters into the form fields is not something that would be potentially malicious from this web server's point of view, but it can be used to create SQL commands that are used to take over this backend database. And that class of attacks we will see is called SQL injection attacks. Okay, and we will have much to say about SQL injection attacks in this course, including ways by which things get attacked and also ways by which we can try to defend against these kinds of attacks. So that's SQL injection. So let me put all of the attacks in blue. We've got that over there. So you can have things like buffer overflows and so on. If your web server is written in a low-level language, but also there are certain other kinds of attacks that work with unsanitized input, and these are called cross-site scripting or XSS. It also goes by CSS, but I generally prefer not to use that term CSS because it also stands for cascading style sheets. So cross-site scripting attacks, which we will study in detail, and also cross-site request forgery attacks or XSRF or even CSRF attacks, as they call them. These are attacks that happen on the web server. But you will see that these are attacks that just don't happen because of requests that come over here. It also requires active collaboration from the browser side. And so I'm going to also put XSS and XSRF on this side because of the following reason. The web server is a very funny entity, right? It's a very funny entity because even though it is written in a language like PHP or Ruby on Rails, it is actually generating code. If you think about it, it's generating HTML, it's generating XML, it's generating cascading style sheets and JavaScript, which are in fact code. And this code is being sent over to your browser where it's being displayed, rendered, and it is also, this code is actively interacting with the end user, who I will draw over here at the very corner, which is you. It could be you, or it could be a malicious entity who has decided to play havoc with that web server. So this user has the ability to go and modify this HTML, this XML, CSS, JavaScript, or interact with it in ways that are in fact allowed by the web server. For example, filling form fields. Now, when that code is modified or the end user over here feeds input to that application, all of that works its way back to the web server via the next HTTP request that goes from here to there. Okay? So therefore, the web application also has a part that is displayed in the web browser. The stuff that is displayed in the web browser is code that is generated by the web server. That is your end user's view of the web server, and therefore, whenever we think about web server security, we are also going to be actively concerned with what is happening on the web browser side. And so therefore, I would categorize cross-site scripting as well as cross-site request forgery, which we will look at in much detail, as attacks that cross over between the web server as well as the web browser. All right. So that is, in some sense, the domain of web security. Of course, I haven't told you. So, on this side, of course, what are the things that you want to protect? You want to protect the web server's resources. So the things to be protected, let me write down in a different color. So the things to be protected over here are the web server resources. So which includes, all of the code of the web server that you want to protect, right? You don't want the attacker modifying the code of the web browser in malicious ways, and also the data that is stored on the web server, for example, any static web pages that are stored on the web server. That's what you care about over here in terms of protecting the confidentiality and integrity of. Likewise, over here, you also care about the contents of the database. You want to protect the contents of the database from the attacker. You may sometimes care about the confidentiality of the contents if the server is storing some sensitive content, or you might care about its integrity because you really care about the correctness of things that are stored in the database. So for example, if there is a product on sale for 1,000 rupees, you don't want an attacker maliciously modifying that entry to make it 1 rupee, because now the attacker is going to be able to make a killing by just buying things for extremely cheap. So you care about both the confidentiality and the integrity of the content from that site. Okay, but what do you care about on this side? Okay, what do you really care about on the web browser side? So the web browser side, the thing that you care about is an entity called cookies. Okay. So what are cookies? Okay, so it sort of turns out so that that HTTP is a stateless protocol. Okay, so HTTP is a stateless protocol in the sense that when I send a request from the web browser to the web server does not really maintain any active state for me for that particular session. This is what allows web servers, HTTP web servers, to really scale up. Okay, so for example, if you are, let's say, if you go to Amazon.com or Google.com, you have an account with the corresponding backend web server. So every time, how does, so you know, you log into your Gmail account, for example, to check your email, and you navigate away from the web page, and then you type gmail.com, maybe you did explicitly log out. It still takes you back to your Gmail web page. Okay, and you can see all of your mail the way you would see it as though you're already authenticated. So how is that made possible? So the way that that is made possible is using this entity called a cookie that the web server generates. So the cookie is generated by the web server. And is sent back. So it is generated by the web server the first time you authenticate with the web server. So you might type www.gmail.com and you might go to the Gmail screen for the first time, enter your Gmail ID as well as your password, and the Google server is going to check your credentials and then authenticate you. Okay, so if you have entered your password correctly, you're let in. But at the same time, the Google server, what it does is that it generates a cookie, which is in fact a cryptographic identity. And these, you will see that in fact it is nothing but an HMAC of some values that are then sent back over to your browser, and they are stored in the browser. So I'm going to draw a cookie by this brown oval over by this red oval over here. So the cookie is going to be generated by the web server and is going to be stored in the web browser. Okay. So I said that HTTP is a stateless protocol, which means that the server is not really going to keep any active state for every web session. So what this means is that if it has to recognize you and authenticate you the next time you come, HTTP requests by themselves cannot authenticate you, okay, because there are no authentication tokens. And that is precisely the job of the cookie. So whenever you send an HTTP request from your web browser over to the Google server, if there's a cookie stored on your web browser that is sent together with the web request, and the cookie serves as the way by which the web server authenticates you. It checks the cookie, it just checks the HMAC value that's stored on the cookie. If it in fact indicates that it's you, you're authenticated, and the web server therefore treats that as a sign that it can return back content that is customized for you. For example, it can show you the contents of your inbox. Now, as you can imagine, right, the cookie, because it serves as an authentication credential with the web server, protecting the cookie is very important. Okay? If you were to give me your cookie, then I can send an HTTP request over to the Google server with your cookie, and that will tell the Google server that in fact it is you, and it will serve me back your inbox, which is an undesirable situation. Okay? So therefore, we care about protecting the confidentiality of cookies. Okay, so cookies can expire in the sense that you can throw away a cookie, or you can say, look, I no longer want to use this cookie, and that's fine. Because what happens is that the next time you log in, the web server will ask you for your credentials, you enter, and therefore you authenticate yourself with a web server. But as long as the cookie is still valid, so there is a timestamp associated with every cookie, as long as the cookie is still valid, and as long as you say, look, I don't want to use this cookie anymore, if you give the cookie to somebody else, that other person can impersonate you. Okay? Therefore, the confidentiality of cookies is of paramount importance in web security. All right? So let me just erase the board and then we can talk about some more material. All right. So I have erased the board and I have drawn a considerably simple picture now. And the reason I have drawn a simpler picture is because for the first part of this module on web security, our focus is primarily going to be on web application security. Okay, so we are just going to be concerned with the web server itself, the web application that is running inside the web server. So on this web server, we have a web application that is running, and I have drawn over here a scenario where an end user is browsing on their web browser, and on that web browser they have two tabs open, okay, x.com and y.com. Okay, and let's just assume that this user has authenticated themselves with x.com. Maybe it is an e-commerce website or an email website or a bank, doesn't matter what it is. They have authenticated themselves with this web server, and therefore the web server has sent back a cookie for this user to next send a request to x.com. They don't have to authenticate themselves. So that cookie is being stored here in the browser. So cookies are always stored locally within the browser. And likewise, y.com has also sent back a cookie that is stored in the browser. And I've shown both the cookies in different colors. X.com's cookie is shown in red and y.com's cookie is shown in green. Okay. So as I already mentioned just a few minutes ago, protecting the confidentiality of cookies is extremely important, because if I were to be able to steal your cookies, then I can present myself as you to the backend web server and therefore get all of the data that the web server must only show you. So for example, your inbox, or in the case of a bank, show me your bank account and allow me to transact as you on the bank web server. All right, so these two cookies, as I said, are stored locally by the web server. They are stored on your desktop by your web browser. So because they are stored by the web browser locally on your desktop, how do you think the web browser distinguishes between the red cookie and the green cookie? The web browser's task, for example, must be to ensure that when you load x.com, only x.com's cookie is sent over to the web server. And that when x.com's HTML or JavaScript or cascading style sheets and so on are shown in the web tab, that it does not go and accidentally fetch y.com's cookies and send them over to x.com. That would be a situation where y.com's cookies are sent over to the wrong web server and can then be used to compromise this user's credentials with y.com. Okay, so you never want that. And so browsers, the way that they store it is that they tag the cookie along with the domain name and store it locally, and then use that tag to fetch the cookie next time. Okay, so the cookies on your local storage are something that, of course, are of paramount importance. So all of these cookies are stored on your local disk in your desktop or your laptop or your phone. And obviously these cookies must not fall into the hands of an attacker who does a local exploit on your machine. Of course, that is a different problem of its own. We have to protect those cookies over here. But importantly, from the domain of web security, we are only concerned when we concern ourselves with the web application security. Our main problem is to ensure that the web browser doesn't send the wrong cookie over. Okay, so let us talk about policies and mechanisms. But before we talk about that, it is also important to understand that a web page from x.com or y.com does not just contain content from x.com. And this is all the more true in today's web ecosystem, where if you go to, for example, a news web page, let's say you go to bbc.com and go and fetch news content from bbc.com, you are not just getting content from bbc.com. On the side, you will see a whole bunch of advertisements. Now, those advertisements are not being served to you from bbc.com. Rather, they are being sent to you by some advertising companies who have formed a history, a profile of your browsing behavior, your likes and dislikes. And so that is how you're able to get relevant ads. In fact, sometimes it's creepy. And in fact, there are people who have done studies on how creepy this can get. So maybe, you went over to Amazon and you searched for some product, right? For example, a security book. Now, the next time you go to some other random website, you will find, for example, advertisements for security books on sale. So how did that follow you, right? It followed you because of cookies, right? Now, those are not cookies that you store with x.com or amazon.com. Rather, there are advertising websites. So there are many advertising websites such as ad.com, and there is another one called admob.com, and there are tons of these advertising companies that participate actively in an auction to decide who is going to serve you ads. Believe it or not, in fact, it's an auctioning process that's going on in real time to decide who is going to get to deliver the right ad impression to you. The same thing, for example, goes on when you see advertisements when you're seeing a YouTube video, right? There is actively an auctioning going on and a bidding procedure going on by which one of these ad companies wins the rights to display an advertisement to you, and then they show this ad to you, which is in fact called an ad impression. Okay. Why do they fight? Why do they sort of bid for this? The reason is because if you go click on that ad, they make money. Okay. And in fact, Google is one of the biggest advertisers, and they make on the order of a few cents each time you click on an advertisement. Okay. So it's a really lucrative business. So that's why people display ads to you. But the bigger point of this is that, when you see something like x.com, in fact, you're not seeing content just from x.com. Maybe there is content from x.com that is displayed in one portion of the web page. And maybe you see over here an ad from ad.com. Maybe over here you see an ad from admob.com, and so on, right? So this web page that you're seeing over here does not just contain content from one web server, but rather multiple producers who have produced content and are displaying it within your web browser. Okay, just give me a moment as I charge my laptop. Okay, all right. So such a website that contains content from multiple entities is called a mashup. So this term used to be rather popular around 10 years ago, this notion of mashup web pages, but it's no longer in wide use because pretty much every web page that you see is in fact a mashup web page. So it's almost redundant calling a web page a mashup because all web pages that we see nowadays are mashup content. Okay, so this notion of a mashup now makes preservation of cookies all the more important, because maybe there is a blue cookie associated with ad.com, and this is not really a cookie that is given to you from ad.com after you authenticate yourself to ad.com. It is just a cookie that comes to your browser after you have visited ad.com. Maybe they have found a fingerprint of yourself from your machine with your web browser, and they send you this so-called third-party cookie that is then stored in your browser. Okay, so this is the ad.com cookie that is stored in your local machine. Now it's important, for example, when you have a web page like this that contains mashup content, that the web browser only fetch x.com's cookie when this content over here requests for that cookie. Okay? And that it only give ad.com's cookie when this code over here requests for ad.com. Remember, all of these things that you see over here are actively code, right? I mean, the code over here is a combination of HTML, JavaScript, and so on, but it's still code. It's code that's executing on your browser, code that was generated by this guy over here and sent over to you. So it's important that when this content is sending a request over to, let's say, x.com, that this cookie, this x.com cookie, accompany that request. It should not be any other cookie. Okay? This is very, very important. Likewise, when ad.com sends a request, whenever this web page is loaded, all of these requests go out from this web page, from your browser to various, it farms out requests to various backend web servers. Now, over here, you have a request to x.com, you have another request to ad.com, and so on. Okay, that this cookie be sent only over to ad.com. So, what we need to understand are the policies and the mechanisms that are in play in modern web browsers that enable this. Okay, so I'm going to actually split the discussion into two parts, that of policy and that of mechanism. Let me just erase this part over here. Okay. So at the foundation of all web security, there is a policy called the same origin policy, or it's also called the single origin policy, but it's often abbreviated by this term called SOP. Okay, same origin policy or single origin policy. That's the core foundation of all web security, the same origin policy. And at the core of all mechanism is the iframe. Okay, the iframe is nothing but an HTML construct that is used to display web pages that contain contents from multiple web servers. So if you have a mashup like this, a web page that is displayed as a mashup like this, and if you go and look at the HTML source code of this mashup as it is displayed on your web browser, how do you see the HTML and the JavaScript source code? Well, you go to your web browser and then you click Developer Tools. It actually allows you to see the code that is being displayed. You will find that this content from x.com is displayed in its own iframe. An iframe is nothing but, as I said, an HTML construct. An iframe, which is nothing but, it's tagged like this, and you can specify a source web server from which this content must be served, and this source web server will be x.com. Okay, so what this is saying is that this iframe is taking content from x.com and it's being displayed in a box like this, whose dimensions are specified by the dimensions of this iframe within this web browser. Okay, likewise, the content from ad.com will be sandboxed in its own iframe, and the content from admob.com will be sandboxed in its own iframe. So the core mechanism, it's in fact, as I already used the term, it's a sandboxing mechanism, is that of the iframe. Okay, so what does the iframe ensure? The iframe is always going to ensure that the content that is displayed within that particular iframe can only interact with other iframes in accordance with the same origin policy, which I will describe shortly. So the thing that the iframe ensures is that one iframe can interact with other iframes only as allowed by the same origin policy. Okay. So if the same origin policy says these two iframes cannot interact, they cannot interact. Okay, that's the idea. All right, so that brings me to the same origin policy. What is the same origin policy? So the same origin policy essentially has works as follows. So whenever content is sent to your web browser from a particular web server, as I was mentioning with cookies, all content, including the JavaScript code that is sent, the HTML code, and so on, everything that is sent from the web server to the web browser is tagged. It is tagged, in fact, with a triple of things. It is tagged with three things. It is tagged with the protocol. It is tagged with the host name of the web server, and it is tagged with the port information. Okay, so the protocol, if you're just using HTTP, is just HTTP. Okay, it could be HTTPS, for example, in which case that is what it will be. It could be FTP. Whatever protocol you choose, the web content is going to be tagged with the protocol. It's going to be tagged with a host name. So, for example, the content in x.com will be tagged with the host name x.com. All content from Google, for example, is tagged with the domain name google.com. Even if you go to a domain name called mail.google.com, in fact, it's www.google.com/mail. Okay, and the top level domain is used as the host name. Okay, so if you, for example, authenticate yourself to google.com/mail, you can still go and see maps, even though it is google.com/maps. And the reason you can do so is because the cookie and all of the content is just tagged with google.com, not the second level, the subdirectories. It's just tagged with the top level domain name. Okay, and also port, which is generally speaking port 80 for HTTP, but it can be any port. Okay, so all content that is sent from the web server to the web browser is going to be tagged with this triple protocol, hostname, and port. And what the same origin policy says is that two pieces of content can interact only if this triple matches. Okay, so in other words, if you've got JavaScript code over here that's sent from x.com, it can only interact with cookies that have the same tag. Okay, so the protocol, the host name, as well as the port, which is sent from the web server, is used to tag the cookie. And the same thing is also used to tag the JavaScript code that is displayed within this iframe. And the iframe will ensure that the code over here, JavaScript code, can only access the cookies that have the same tag. Okay, so this automatically ensures that code from x.com cannot go and fetch y.com's cookie. It also ensures that code from ad.com cannot fetch x.com's cookie. So same tab, different tabs, doesn't matter. It's only the protocol, host name, and port that matter. And it's a combination of these three things that the same origin policy enforces. So for example, what this means is that you can have another iframe that is displaying content from x.com within the same tab, for instance. and these two iframes can interact with each other. That's allowed. Okay, so this content over here can fetch this cookie, it can set the cookie. This content can also fetch the same cookie, set the same cookie, and in fact, these two iframes can also send messages to each other. That's allowed. That's allowed by the same origin policy. Okay, so that's the same origin policy, and the enforcement mechanism is, of course, that of the iframe. But who implements iframes? It's the web browser that implements iframes. The iframe is a core security mechanism that is implemented by all web browsers because they have to render content. And the policy that they use when they check for security when rendering iframes is that of the same origin policy. So all modern browsers implement the same origin policy and use iframe as the core mechanism to render content. Now, there are some limitations to the same origin policy. In fact, one of the required readings for this module is this paper called Beware of Finer Grained Origins. And that sort of shows you some of the limitations of the same origin policy. Now, the same origin policy is actively being considered for replacement by another policy called CSP, or Content Security Policy. And going forward, in fact, the SOP may be replaced by the CSP. We don't know, right? There are already proposals, there are already websites that use the CSP or the Content Security Policy. Now, whether it will catch on is anybody's guess. And so we are not going to be studying it in any amount of detail in this course. So for this course, our main goal is going to be the same origin policy. And what we are going to look at when we study various forms of attacks are how content on the web browser, malicious content, for example, on the web browser, is actively used to steal credentials like cookies within the constraints of the same origin policy. Okay, so with this done, let us now start some slides. All right, so in the rest of today's lecture, I'm just going to give you an overview of, again, the web ecosystem. We will look at some real code examples and so on. But we will stop at the end of the background. The next class, I'm going to start various topics such as SQL injection, cross-site scripting, cross-site request forgery, and so on. I will describe how the attacks work, and then we will look at several defenses. We will also look at browser security issues, which are issues involved in the implementation of web browsers. That will be the last part of this module. But let's start off by understanding the same origin policy slightly better, as well as issues of JavaScript security. Okay, so in order to understand JavaScript, which works hand in hand with HTTP, let's briefly again look at the HTTP protocol. The HTTP protocol consists of various methods such as GET, POST, and so on that are used for interaction between the web server and the web browser. As I was mentioning, the HTTP protocol is fundamentally stateless. Okay, so each request happens independently of prior requests, and there is no memory of what happened in a prior request when the next request goes. So the statelessness has a significant impact on the design and implementation of web applications, which are therefore fundamentally able to scale better because they don't have to keep active state about every ongoing web section. So this is why you see a web server being able to handle thousands and thousands of web requests concurrently. Okay, so this is what an HTTP request looks like. As you can see over here, the first thing that is specified is the name of the HTTP request. It's a GET request. It specifies which HTTP version is being used, as well as the file that is being requested from the web server. Okay, there are some headers, and it also sort of specifies which browser is being used and so on. Okay, so this goes out to the web server, which then responds again with the HTTP version. It responds back with the status code, and there are different codes. You might have probably the code that you're most familiar with is 404 if the web page is not found. And also, it tells you the web server that is that's returning the request, what is running over there, and it's sending you back content which is of, in this particular case, HTML and text, and the content, as you can see over here, is HTML. Okay, now HTML is the first thing that is rendered on your web browser, and if there is any JavaScript code, that gets rendered after that or together with HTML. But that JavaScript can actually actively change how your web page looks. This is why JavaScript uh, is used to provide a dynamic feel to web pages that are sent back. So, for example, Google Maps, right? If you drag your map, your panels also move, and that is all JavaScript in action. So, as mentioned in the first part of this lecture, the most fundamental entity that is used to store information across sessions is this notion of a cookie. Okay, and it is nothing but a file that is created by the web server that stores information on your cookie, and it includes information about which is the server that created it. That is what the same origin policy essentially use. So that includes the domain, and it also includes an expiration date, right? And also whether it can only be read over SSL, right? Those are secure cookies. And every time the web browser makes a request to the web server, the server requests the cookie, and then the browser returns the data. Or the browser can attach the cookie over with the request, and the server just sends back the data. So as I said, cookies are important pieces of information whose confidentiality you care about. So if you're just going to transmit things over HTTP from the browser to the server, your cookie is always at risk of being read by arbitrary people on the internet. Okay, that's always a risk. So of course, we can ask ourselves, what are cookies used for? As I already mentioned, cookies serve as pieces of data that can authenticate you to the web server, right? So they serve the purpose of authentication. They also serve the purpose of personalization, that recognizes the user from a previous visit. So this could be used to personalize content. For example, a web page displayed in the form that you left it before, or your personalized inbox, or even ad personalization. Okay. This leads me to the next kind of application that cookies are used for, which is tracking. This is the creepiest use of cookies, where cookies are used to track the user from site to site and learn the user's browsing behavior, patterns, and so on. And there's a very interesting paper that I can point you to that we're not reading in this course, that sort of tracks the that shows how tracking cookies track users from site to site. And I will leave a pointer to this in the Teams chat box. Okay, so once a cookie is saved on your machine, only the website that created the cookie can read it. And when I say website, I actually mean the triple, right? The protocol, host, and port. And as we know, that is called the same origin policy. There are also other kinds of cookies. There are, for example, what are called temporary cookies. So these are only stored until you quit your browser or navigate away from the website. And you will find that most banks today, in fact, use temporary cookies. Go try it on your bank. You might log into your bank and then navigate away from the bank's website. And then if you come back to the bank's web page once again, you will find that your session has expired. And the reason is because banks generally prefer to use temporary cookies for security. They want you to log in once again because here money is at stake, right? It's important. So there are persistent cookies, and this is probably the best example of persistent cookies are the cookies that you get from Gmail, because they remain in your browser until you explicitly delete the cookie. And this is what allows you to go and read your email every time without having to log in, even if you navigate away from that particular web page. And there are also third-party cookies that your website can agree to uh, to have stored, and these are cookies that originate or are sent to another website. Okay, and these generally, tracking cookies and so on take the form of third-party cookies. So this is what a general session with cookies looks like, right? Your client might send a post request with the login application. So in this case, it's called CGI. It's a CGI-based web server. And the server, of course, runs the login application with the credentials provided, the login name and the password, and verifies, checks whether the client is authorized. And if so, the server sends back a cookie, which is generally an HMAC of a secret key that the server has together with your credentials, so that are sent back over to the client. So it's provided with so the cookie actually consists of some secrets that you provide and a secret of the server. So you cannot replicate the cookie on your own. And the cookie is set on your client. That's going to be shown as a cookie now on these slides. And the next time you send a GET request that in fact requires authentication, together with a GET request to fetch that restricted content, for example, the contents of your inbox, you send the cookie. Okay, and the server simply checks the validity of the cookie. What it does, as I said, it's an HMAC, so it takes the key and the session ID, and it computes a hash, and it just checks, right? Just like we recompute max every time, you can actually recompute the cookie, check that the cookie is in fact valid, and then it serves the restricted content. So, these authenticators, these cookies must of course be unforgeable. So in the sense that no random entity should be able to create these cookies on their own. So that's why it consists of both a session ID that is unique to this client and the server, as well as a key that is unique to the server. So neither the client nor the client cannot produce the cookie on their own, and no other client can produce the cookie. The server is the only one that checks the integrity of this cookie, and is therefore able to establish, in this particular case, all it requires is source authentication, and it's obtained that. It's also tamper proof, right? I mean, it should be tamper proof, and that is obtained by using a hash, right? Because hashes are supposed to be a strong hash function, is supposed to be hard to guess. I mean, you should not be able to produce the plain text that produces the same hash, and so that provides the tamper proof property. So the malicious client is not able to compute or modify a cookie on their own. All right, so that's what cookies are, and cookies play hand in hand with web applications. On the other side, which is things like online banking, shopping, and so on, which take input from the user and interact with backend databases, as I already discussed, and produces outputs that are displayed on the client's web browser, and the data that is sent is nothing but HTML and JavaScript. And the web application itself is written in a mixture of various languages such as PHP, Java, Perl, Python, C, ASP, which is active server pages. It's a Microsoft technology, and so on. Okay, so as we will see, security is an important consideration in web app design, and there are a ton of security problems that happen because of poorly written scripts that don't validate input properly. There's also a huge vulnerability from sensitive data that are stored in word readable files, right? If you're able to just send the right kind of inputs to your web server, the server just displays the files over the web browser. So anybody can then read the data, sensitive data that is stored on the web server, and so that is also important to prevent those kinds of attacks. And there are also, an active push from companies like Visa and MasterCard, financial companies, to ensure that these web servers adhere to certain standards, especially if they deal with payment information. Okay, and these standards are called PCI and PCI DSS, where the web pages that actively deal with financial information like credit cards must pass the PCI standard, PCI DSS standard before they are allowed to handle that data. Okay, so whenever we talk about web applications, we also talk about JavaScript, which is a language that's executed by the browser and it runs before the HTML is loaded, before the page is viewed. Um, and in fact, it can be executed when the page is viewed and even when you're leaving the page is viewed. It's triggered by various events. And we will see that JavaScript is the vehicle that is often used to exploit a number of vulnerabilities. So I'm going to stop here. From the next class, I'm actually going to start with this slide over here that shows how scripts are written. And, um, we will start off from slide number 11 and then work our way forward to various kinds of attacks, such as SQL injection, cross-site scripting, and so on. But that's it for today's class. Thank you very much.